Hello, students, and welcome back to class. I just wanted to take this opportunity to say how happy I am with the way this class has gone so far this semester. The quality work that's being turned in is impressive. Keep up those good habits. Here's another good habit that you should get into. Make sure that you're checking our Canvas page every day. Your teachers post assignments and grades and announcements on your Canvas page, sometimes daily. You should check often to make sure that you're staying on top of everything you need to do in all of your classes. In this class, it's time to start looking at fractions. And let's start with a little terminology. In the fraction 2/5, the top number is called the numerator. The bottom number is called the denominator. The numerator in 3/8 is 3. The denominator is 8. We'll use these words often. Now, when I think about fractions, I start by thinking about pizza. I tried to draw two pizzas here and here. They're supposed to be the same size. Now, if I get hungry and eat 2 slices of this pizza, then I have eaten 2 slices out of a pizza that was cut into 1, 2, 3, 4, 5, 6, 7, 8 pieces. I've eaten 2/8 of that pizza. From this pizza, I'm just going to eat 1 slice, but it's a big slice. I'm eating 1 slice of pizza out of a pizza that was cut into 4 pieces. I ate 1/4 of that pizza. Do you see that the amount of pizza eaten out of this one is exactly the same as the amount of pizza eaten out of this one? Those two amounts, 2 out of 8 and 1 out of 4, are the same, which makes 2/8 and 1/4 equivalent fractions. Let's try the same thing with some pan pizza. These 2 pan pizzas are the same size. This one cut into 6 pieces. This one cut into 3 pieces. From this pizza, I'll eat 1 slice, 2, 3, 4. 4 slices. From this pizza, I'll eat 1 big slice here and 1 big slice here. I've eaten 2 slices out of 3, 2/3 of this pizza. 4 slices out of 6, 4/6 of this pizza. But do you see that the amount of pizza eaten here is the same as the amount of pizza eaten here? So 4 out of 6 is the same as 2/3, which means 4/6 and 2/3 are equivalent fractions. What we'll be doing in homework today is showing how to get from one fraction to the other. Here's what your homework will look like. Write each fraction in simplest form. When I see those instructions, what I think is reduce. Can we take 6/15 and reduce it into a new fraction that is in simplest form, meaning smallest numerator and denominator possible? In order to do that, can you think of a number that divides into both 6 and 15? One number that divides into 6, the same number, must divide into 15. Well, I know that 6 and 15 are both divisible by 3. If I take 6 and divide it by 3, I get 2. If I take 15 and divide it by 3, I get 5. 2 slices out of 5 is the same as 6 slices out of 15 on my pizza. 2/5 is considered in simplest form because it cannot be reduced any further. Let's try the same thing with 30 over 42. Can you think of a number that divides into both 30 and 42? Well, let's see. 30 and 42 are both even numbers. Even numbers are always divisible by 2. 30 divided by 2 is 15. 42 divided by 2 is 21. There, I reduced. But I'm not in simplest form yet, because 15 over 21 can reduce some more. Can you think of a number that divides into both 15 and 21? Well, 15 and 21 are both divisible by 3. Divide by 3, divide by 3. 15 divided by 3 is 5. 21 divided by 3 is 7. Now, there are no numbers other than 1 that divide into both 5 and 7. So 5/7 is the simplest form of 30 over 42, and 2/5 is the simplest form of 6 over 15. Let's try a few more examples. Some of the problems that you'll encounter have numerators and denominators where it's easy to find a number that divides into both. I can very quickly find a number that divides into both 9 and 12. They're both divisible by 3. I'll divide the top by 3. I'll divide the bottom by 3. When I do that, 9 divided by 3 is 3. 12 divided by 3 is 4. 9 out of 12 is equivalent to 3 out of 4. 3/4 is considered simplest form because it can't be reduced any further. How about 16 over 26? Is it easy or hard to find a number that divides into both of those? Well, what I know about 16 and 26 is they're both even numbers. Even numbers are always divisible by 2. We'll divide the top by 2. We'll divide the bottom by 2. 16 divided by 2 is 8. 26 divided by 2 is 13. Does that reduce any further? Well, nothing divides into 13 other than 13 and 1. So that does not reduce any further. That is simplest form. 28 and 35, that might be a little harder to find a number that divides into both. Can you think of a number that divides 28 and 35? Pretty sure they're both divisible by 7. 28 divided by 7 is 4. 35 divided by 7 is 5. 4/5 is the simplest form of 28 over 35. Now, when you do your homework, what I'd like you to do is write the problem down and write the answer down. The things I'm doing in red, if you can do that in your head, great. You don't have to show that. But for each problem, you'll write the problem and the answer. Now, these have a little trickier numbers. 24 over 30, what divides into both of those? Well, they're both even, so I could divide them both by 2. If I do that, 24 divided by 2 and 30 divided by 2 gives me 12 over 15. Does that reduce again? A number that divides into both 12 and 15. Those are both divisible by 3. 12 divided by 3 and 15 divided by 3, I end up at 4/5. Now, if you're really good with numbers, you might do this same problem, but do it in just one step. 24 over 30. Could I reduce this all the way down in just one step? Is there a bigger number, bigger than 2, that divides into both 24 and 30? 24 and 30 are both divisible by 6. Now 24 divided by 6 and 30 divided by 6 takes me straight to 4/5. If you can do it in one step, do it in one step. If it takes you 2 steps to get there, so be it. Do it in 2 steps. Let's try number 5. They're both even. I could divide by 2. If I divide them both by 2, I get 18 over 30. Those are both even. I could divide them both by 2. Divide them both by 2, and I have 9 over 15. But 9 and 15, those are both divisible by 3. Giving me a final answer of 3/5. 36 over 60 is the same as 3 out of 5. Let's see if we could do that in just one step. Starting with 36 over 60. What's the largest number that divides into both 36 and 60? They're divisible by 2, they're divisible by 3, they're divisible by 6, but if you're really slick, you'll notice they're both divisible by 12. 36 divided by 12, that's 3. 60 divided by 12, that's 5. Again, if you can get there in one step, do it. If it takes multiple steps, that's okay too. Let's try a few that have a common trick to them. Anytime I'm reducing and I notice that both numbers end in 0, anything that ends in 0 is certainly divisible by 10. If I divide top and bottom by 10, then my numerator is 6, my denominator is 13, and I'm done. Let's keep that in mind. Numbers that end in 0 are divisible by 10. Let's try that on number 7 as well. Numbers that end in 0 are always divisible by 10. Divide the numerator by 10. Divide the denominator by 10. Uh-oh, this one's not done. 8 and 14 are both even numbers, which means they can both be divided by 2. If I divide them both by 2, then I end up with 4/7. There's my best answer. Great. Now look at numbers 8 and 9. If a number ends in a 5, it's divisible by 5. And if a number ends in 0, it's also divisible by 5. I could divide both of these by 5 in order to reduce. 25 divided by 5 and 30 divided by 5 gives me a final answer of 5/6. Again, now when you do your homework, write the problem down. Put the answer next to it. What I'm writing in red is optional. You don't have to write that if you can do that in your head. Try number 9. Both numbers end in a 5, and I know any number that ends in a 5 is divisible by 5. "15 divided by 5 is 3. 45 divided by 5 is 9. Done? Wait a minute. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. There's my best final answer. Some of the problems in your homework will have variables mixed in. When that happens, handle them this way. We're trying to reduce. Let's start with the numbers. 20 and 24 are both divisible by 4. "20 divided by 4 is 5. 24 divided by 4 is 6. And if there's an M in the top and an M in the bottom, those M's cancel each other out perfectly. Great. Try number 11. Let's start with the numbers. 60 and 70 both end in 0. If they end in 0, they are certainly divisible by 10. 60 divided by 10, 70 divided by 10. And if there's an x in the top and an x in the bottom, they cancel each other out perfectly. Great. Again, see how I'm showing the problem and the answer for each one. On 12 and 13, a little trickier when there's an exponent. I would suggest rewriting the problem. Rewrite the top as 35 c squared, which means c times c. C squared is c times itself. In the bottom, 45c. Let's do the numbers first. 35 and 45 both end in 5, so they're both divisible by 5. We'll divide by 5 in both the top and the bottom. 35 divided by 5 is 7. 45 divided by 5 is 9. Now look at the c's. Remember, the m in the top canceled the m in the bottom. The x in the top canceled the x in the bottom. A c in the top cancels a c in the bottom, but there's still a c left in the top. So you'll still have a c left in the top of your answer. That's how number 12 should look. Here comes 13. Let's rewrite it. The top, I'll rewrite by copying. The bottom is 80, and x squared means x times x. Let's do the numbers first. Any number that ends in 5 or 0 is divisible by 5. Now 25 divided by 5 is 5. And 80 divided by 5 is 16. I see an x in the top, perfectly cancels an x in the bottom, but there's another x in the bottom. It doesn't cancel, so it stays as an x in the bottom in my final answer. There's the way 13 should look. All right, I think you're ready. Go work some homework problems. I'll see you later on today.